So hello everyone. Today we're going to see the question that goes by next greater element. And the approach that we're going to discuss is, going to be linked with your stacks. And this is a very important question when we come to stacks because many questions are going to be based on this basic question. And then it has four parts: next greater element, previous greater element, next smaller element, and previous smaller element. So to understand all the four questions and also the questions that will be based on these questions, it's very important that you realize that you understand what next greater element question says. For that, let's just jump to the problem statement. Given an integer array A, return the next greater element for every element in A. And what is the next greater element? The next greater element is the first element greater than x that we come across while traversing the array in a clockwise manner. If it doesn't exist, return -1 for the element. Coming to 1, what is the next greater element? 3. Then coming to 3, what is the next greater element? 4. Coming to 2, 4. Coming to 4, it's the last element, so it's -1. Are you getting it? Now, if I have to discuss the most naive approach for this, that is to say you have an array that goes by 6, 8, 0, 1, and 3, right? This is where your I index is. Start your J index from I plus 1 and go on until you find the element that is greater than your ith element, as in when you find it, break from the loop and maintain another array. 8, so 8. When your I comes here, your J comes here, you go on 0, you say no. 1, you say no. 3, you say no. And if you reach the end of the loop, then what you have to return? -1. Are you getting it? In that case, the time complexity is going to be big O of n square. And the space complexity, big O of 1. I hope you're getting it right. But then coming to the approach that we want to actually discuss through this video, it is using stacks. Now, if I have to be honest, this approach can come to your mind during an interview or during your OAs, is when you already know of this approach, know of how to actually use stacks for this question. Coming again to it. Now, one thing is clear, that since the time complexity was the problem in the above solution, that was O big O of n square, so we have to reduce the time complexity, right? Now, reducing the time complexity, it could be n log n, or just let's come to it. It could be big O of n. How can we aim to get that time complexity? First thing, I have to traverse my array only once. Now, if I have to find which element is greater than 6, just the next element which is greater than 6, maybe I need to traverse my array from this, right? Because if you see, 6 answer should come from 8. Make sense? Let me put this into simple words. If I am here, 1's answer is 3. But I can give this answer as 3 only when I have actually visited 3. Do you get that? Because else if I'm standing at 1 and I've come from this side, I don't know what the next element is. You get it? So this way traversal is not going it to be, right? We have to traverse it from 3 towards 1. That is from the endeth element to the first element. Does that make sense? That we need to traverse our array from here. Now let's come to the stack part. Let's say this is my stack. This is my stack ST. Now I come to third. I see my stack is empty. I say okay. Push the element 3 into the stack. Push the element into the stack. And in my resulting array, just put -1. Just keep on, keep the patience and keep on going. Now we come to 1. When I come to 1, I see, is my stack stop greater than 1? I say yes. Then I just say pop it from here, push it here. Do you get that? And put 1 here. Is that making sense in any way? Right. Because what do I say? But okay, there's a concern here. The 3 needs not to be pushed, because if here it is, let's say 2, then this 1 will get popped off, but 3 will become the answer. So let's just stay on this. So 1 has been pushed. Now you come to 0. You see 0. Then you say 1 is bigger. I say, okay, return 1 as answer. Push O into the stack. Then you come to 8. Then you say 0. Stack stop. Is it bigger than 8? I say no. You pop it. 1, pop it. 3, pop it. Stack becomes empty. What do I get here? -1. And 8 goes into the stack. Do you understand? I don't need any of these elements because I have an element greater. So all the elements that are on this side of the stack, the potential candidate for them is 8 and not any of these, because 8 itself is greater than all the elements that are there on its right. So for any of the elements towards the left of 8, 8 is my potential candidate. And if you see the stack, it is always going to be a decreasing stack. You get this? Right? Then coming as to what it is inside, then 1, then 0, this way decreasing. I hope you get that, right? Then I come to 6. I see what is in the stack stop. 8. 8 is greater than 6. I push 8. I make this 8 and then this is 6. I hope you get that. Right? Let's just solve another example. 1, 3, 2, 4. 1, 3, 2, and 4. And this is my answer, right? And this is my stack. Make sense? I start with 4. I see the stack is empty. What do? I make this -1. And on every turn, whatever you do with the element, you have to push that element into the stack because that is a potential candidate for all the elements on its left. Now coming to 2. 2C, stack stop. What does a stack stop say? Stack stop say, I am greater than you. 2 says, okay. You take my seed in the resultant array. And 2 gets on the top of the stack. Then comes 3. 3 says to the top of the stack, are you greater than me? The top of the stack says no. Then you pop this out. Then 4. Okay, I push in 4. Right? And then 3 is put here. Then 1. Stack stop greater than 1. 3. Are you getting it? And 1 being pushed into the stack. So 3, 4, 4 minus 1. And this is what we have got. Let's just get to the code part. Okay. Return type, vector. Next, greater element. What do we have? Vector int as array. What do we need the data structure? Stack. Make sense? And also we need another data structure. That is resultant. Right? And n is what? Array's size. For that, now the loop. Int I is from n minus 1. I greater than equal to 0. I minus minus. Now what? While stack is not empty. And what do we see? What do we see? Stack stop is actually lesser than num's I. If that is the case, we go on popping the element. Now this while loop, you can get out of this while loop due to two conditions. Either your stack becomes empty or this condition goes false, right? So if the condition is if stack is empty, then what do? You make your resultant I as -1. Or else, why can you come out? This condition. If stack.top is greater than nums I, then what do? Resultant I becomes stack's top. I hope you're getting it, right? And in all the conditions, what is happening? After all these checks, I'm going to push in stack what was my nums I. Was it nums I used? No. To make let me make this nums. Okay? I hope it makes sense. And then just return your nums and you should be good. Return your resultant, sorry. With that, let's come to the complexities part. Time complexity, big O of n. Only one time you're traversing the array. Space complexity, big O of 1, big O of n. This is for stack. I hope I hope you know what has happened and you're decreasing stack and everything. I hope you're able to understand the concept of how it's done. See, you have to keep popping. First of all, because it's next greater element, that means if I have to find an element, I should have already visited that element, right? So we start from the right hand most element, right, of the array data structure. So when I start, now this is my last element, right? So when I'm starting with this element, I have to, with each and every element that I'm traversing, I have to push those elements into my stack. That is the fundamental thing. Now with the element, I need to check if my stack is empty. That means it does not have any element greater than it. All have been popped off, right? With that being the case, I need to push minus. I need to keep the element as -1 in my resultant array. Now, if there are elements in the stack, then I need to check is stack, because it's a decreasing stack, right? So I need to check, is my stack's top greater than the element? If it is, then that element's answer in the resultant array will be the stack's top. But if that is not the case, I have to keep popping the elements until I reach to the case, until I reach the condition where either my stack would be empty or my stack's top would be greater than my element. If my stack is empty, then I'm going to replace the index in my resultant array as -1. And if my stack is not empty, but my stack's top has become greater than my array element, then I'm going to put the stack's top as my array element in the resultant vector. I hope you're able to understand. And if not, then maybe we'll go through it in the next coming lectures, that are previous greater element, the next smaller element, previous smaller element, and so on and so forth. With that, if you have any concerns, if you want me to revisit anything, if you were not able to understand the logic part or examples part or anything, just make sure you're making use of the comment section. Right? With that, I shall be taking your leave. Thank you so much.